This problem is about binary addition, and so given two binary strings A and B, we need to return the binary equivalent sum. If you think about binary addition, it works very closely like regular addition in base 10, where the only difference is that when we add the columns of the numbers, we are converting the sums into base 2. So if you think about what values we can potentially have, we can either be adding 0 and 0, which would be just 0, or 1, 0, or 0, 1, which would just be 1. But then if we have 1 and 1, that would mean we need to carry over a 1 and add a 0 since 2 is 1, 0 in binary. And then the biggest value that we can have is where we are already carrying over a 1, and then we also have 1 and another 1. And so a 3 would be meaning that we carry over a 1, but then also we write a 1. Um, so if you think about how we want to structure this out, this means that we would have a we would need to have a carry over row. We would have A and we would have B, and then we would have a solution row if we were doing this on paper. Um, we don't actually need to store the solution as a uh, row in itself. We can just keep building the solution as we go. Another characteristic is definitely that we are starting from right to left, just like in regular addition. And then the third thing that we would ideally want to do is actually pad all of these um, columns such that we are adding the columns correctly, and we don't have to do any other arithmetic to actually align the values and make sure that we're adding the correct indices. So we would probably want to pad each row. And then lastly, as a final step, if you're padding rows, one important aspect is that when you do addition, the length of the numbers has to be one greater. So the first column is left blank, such that if we carry over a value, we have space to actually write that down. So we need to add a prefix empty value to each row. After that, we have padded the actual rows. So uh, the logic is pretty straightforward and intuitive. If you think about, we are given two numbers, like if you consider the first example, A is 1, 1, and B is 1, we want to first make sure that we pad these numbers such that they're both in equal length, such that B is 0, 1, and A is 1, 1, and then we can add that uh, empty value prefix such that we would end up with um, 0, 1, 1, and then 0, 0, 1. And then that way we can then start working from reverse and actually summing the values and carrying over the value. So if you think about the carryover, this really, we don't need to have this as a row because as we're going in reverse and adding these, we only need to keep track of what the current carryover is, and then we can substitute it at every single iteration that we're doing. So that can save a bit of space as we don't need to be storing all of the values that we have carried over like we would be writing out in regular addition. So you just initialize this to 0, but that would come later as we would first need to actually prefix the values. And to do that, we need to know what the lengths of A and B are. So we can do len A equals len of A, and then len B equals len B. Um, now that we know, we can think of really three, there are only three cases that we need to deal with. And one is uh, that they're both equal. And if they're both equal, we don't have to do much. All we need to do is actually add that empty prefix value. So we can just set new a to equal an empty string for now, and then new b to equal an empty string as well. So if they're both equal, then we can simply do new a equals 0, since that's an empty value, plus whatever a is, and then the same with b, 0 plus whatever b is. The other conditions is that if length of a is less than length of b, then we would need to actually find the difference between what a and b are, such that we can pad the right number of values. And so I think after finding the length, the next best thing to do would be to find the difference, and the absolute difference is what we would want, and that would just be the difference between a and b. And so if len a is less than len b, then that means that we need to add the number of as many zeros as the difference is. So we would do 0 times the absolute difference, and then we can actually append the rest of the existing string. So we can do, sorry, this would not be len a, this would be new a. So new a would be 0 times the amount of difference that we have, plus the actual existing a. And then new b would just be the prefix that we want to add plus b. And I just missed one thing here. Again, when we are computing new a and new b, we're already adding the prefix in the same step. So here we actually are missing one more 0. So we can actually add one more 0 to new a, such that now they would both be on the same footing. And then the last case we can deal with, where it's just the reverse, where it's b which is smaller, such that we must add that difference to whatever b is. And then a would just be the prefix plus a. Now the second step would be to, once we have padded all of the values and all of the values are sorted out, now we can start to actually iterate over the numbers and do the summation. So for this, we obviously need to go from right to left, so that means we would need to reverse the, well, we'll go in reverse order. So we would need to do, we can do for I in reversed, and then the length of whatever new a or is does not matter. And at this point, we want to basically start summing the columns. So we can equate the call sum, and this would be equal to just new a of I plus new simplify, and then we need to remember that we need to add the carry over if there is any. This would be the sum as an integer, and we need to basically deal with a few cases. So for example, if the sum is 0 or 1, then we don't need to carry over anything. So if it's basically less than 2, we can simply just directly add it to the solution. So we need to actually add another variable. I think it's better to just keep the carry in this part since we are not using it before. We can keep track of the final solution as a string, and we can just initialize that as an empty string. So if the call sum is less than 2, then we are basically prepending the sum itself to the final solution. Solution equals call sum, and we should be converting this to a string since we're adding to a string. And then we must remember to reset the carry value if there is any, so it does not affect the other summation, the other iterations. I said before that the sum can be 2 or 3. So if you consider the fact that it's 2, that means that we are carrying over 1 and then adding 0. So we can do final solution equals adding 0. So 0 plus whatever the final solution was. And then we are basically replacing whatever the carry value was with the new carry value, which would be a 1. I think it should be making it clear that 2 is 1, 0 binary. And then the last case, which is the maximum case, if we have 2 numbers, obviously this would be insufficient if we have more, but the last case would be well, sum is 3, so it should basically be 1, 1 in binary, and that's why that would be the last case. And so in this case, we're just adding 1 to the final solution, as well as we're carrying over a 1. If you keep doing this, again, we will end up with the full sum. The only problem is that if you notice, we are, well, if there's a case such that we keep adding zeros and there are no more ones, then we might lead to a fact that the final solution just has a lot of zeros that we have not that are basically meaningless bits in these solutions. So as a final step, we must actually remove any leading zeros as they're not part of the final solution. So and we can basically do this by just iterating over every single character, and then as soon as we find, if we do find a character that is a non-zero, then we can break out of the loop. So if car is well, for car in final solution, if car is equal to 1, then we can break. Otherwise, we want to actually strip that leading character, and so that would do that. And then lastly, we just want to return the final solution. Now, one small case is that the final solution, I mean, if you're stripping out ones at the start and there is a sum that, if you're adding numbers and a sum up to 0, then we effectively have an empty final solution. And so we could, well, we would need to, in the case that the final solution is none, then we at least want to send a 0 as to indicate that there is no value. And it could be a bit more elegant if we actually just do that directly in the loop, but it is a matter of preference. There are some minor things, so we need to actually create the range when we're iterating, and I just forgot to assign the values. And yes. Just one thing to make sure is if we are adding the columns, we need to actually convert the character values into int such that we can sum them all. And well, true. Yeah, this should be all correct. So if you run one more thing I forgot is when we were removing all of the leading zeros, if we go through the entire string and we find no more zeros, this will actually never actually exit. So we need to break as soon as we finish that first iteration itself, so you don't need to check more. And that should work. And this is the optimal solution again. If we cannot use the Python built-in methods to add binary values. So Python does have a much simpler method, as integers in Python can be expressed as binary numbers, and you can actually add binary numbers directly. So I can just show you this here. So if you want to get the binary value of a, that would just be, we can supply the second argument as the base value. So if we do 2, we will get those values in the binary form. So then the um, binary sum would actually just be using the bin method, which adds 2 binary numbers. And so we can just directly add them like that. And then lastly, this binary sum would also be in binary. So we would, if you know the binary prefix is like 0b and then whatever the binary value is, so we can actually, we would need to strip out the identifier. So we would just be returning the sum without the leading 0b characters. So it's 2 characters onwards, everything would be the final answer. And so this would be technically the most optimal solution, but you would usually be implementing this using building out the binary addition like we did. So that's all for this problem, and thank you for watching.